All right, guys, picking up here with number 21, part B, technically. First, we need to find the angle. So we need to take the inverse cosine of 0.25. And if I do that, I get my angle equaling 1.318. Now, because my original ratio is negative, our cosine is restricted to quadrants 1 and 2. But this time, the calculator gave you something in the first quadrant, 1.318. Now, cosine, or the x values, are positive in quadrants 1 and 4. So my final answers are going to be here. So I actually already have a final answer, because in the first quadrant, my answer is 1.318. So that one's done. My fourth quadrant answer is similar to the previous problem, that I need an answer down here. So I have to go all the way around for a positive angle. So just like this fourth quadrant answer, you would take 6.28 and you would need to subtract the reference angle. The reference angle in this case is 1.318, so you subtract that. And if I do that correctly, my final answer in the fourth quadrant would be 4.962. Find the arc length given the radius is 9 inches and the central angle is 80 degrees. So, based on the definition of a radian, the angle in radians is equal to the arc length divided by the radius. So again, because this is the definition of a radian, I know that this theta has to be converted to radians. So it's given to me in 80 degrees. The reason this example is on here partially is to remind you to convert from degrees to radians. We need to multiply by pi over 180. If you're going the other direction, it would be 180 over pi. If I simplify this, it's really 80 pi over 180, which reduces to, let's see, what could I take out of 80 and 180? I think I can definitely cross out the zeros, and that I can take a 2 out of both of these. So that would be 4 pi over 9. So if I come back over here, I can replace theta in radians with 4 pi over 9. I'm trying to find the arc length, which is symbolized by s, and I know that the radius is 9 also. Now, some of you may notice what s is already because of the setup, but again, cross multiplication is always welcomed. If we did 9 times s equals 4 pi times 9, that would be 36 pi. Divide each side by 9. So my arc length this time is a nice answer of 4 pi, specifically 4 pi inches. Number 23, if your distance from the foot of a tower is 35 meters, foot meaning the bottom, or the bottom of the tower, and the angle of depression is 65 degrees, find the height of the tower. All right, so we have a little right triangle here. Here's the tower. It says that the foot of the tower, or the bottom of the tower, is 35 meters. We're trying to find the height of the tower, so we're trying to find this. The angle of depression, again, is based like a reference angle on the x-axis. So technically, the angle of depression is this angle, but the angle of depression is the same as the angle of elevation, and so this is 65 degrees. So now if I look at the two sides I have in the triangle comparative to that angle, I have the opposite side and I have the adjacent side. So if I consider right triangle trig, I have opposite and adjacent, so I need to use tangent. So tangent of my angle in degrees equals opposite x over adjacent 35. Now make sure your calculator is in degrees, because that's what it's given to originally. If you would like to solve this, think of it as cross multiplication. 1 times x is equal to 35 times the tangent of 65 degrees. So if you plug this into your calculator, make sure your calculator again is in degrees. Your answer would be 75.06 meters. Number 24, a 15-foot ladder leans against a wall. Okay, so we have a ladder, assuming diagonally here, leaning against a wall, so that the base of the ladder, or the bottom again, the bottom of the ladder is 7 feet from the base of the building. So here is 7 feet. The ladder is 15 feet long, and so the ladder is diagonal. So this would be 15. And we're trying to find what angle does the ladder make with the ground, which would be this angle right here. So we're trying to figure out how many degrees is this angle. So the two sides I have in comparison to what I'm trying to find is the adjacent side and the hypotenuse. So again, if I consider right triangle trig, and I'm thinking SOHCAHTOA, this time I have adjacent and hypotenuse, which means I'm using cosine. So cosine of my angle, which I don't know, is equal to adjacent, which is 7, over hypotenuse, which is 15. Now, after a lot more of a semester of practice with this, I hope you recognize that to get x by itself, you need to get rid of cosine, which is when you're taking the inverse of both sides, because inverses help you find angles, just like for the unit circle. So x is really the same as the inverse cosine, or the arc cosine, of 7 over 15. Again, please make sure your calculator is in degrees, because generally with word problems like this, we're dealing with degrees. If it is so, and you plug that in, the answer you should get is 62.18 degrees for the angle of elevation there. So, last problem in this video has to deal with domain and range. Use the graph to the right to answer the questions below. So, if we want to find the domain of this function, we are thinking x values, and we're thinking left to right. So if I move my eye from left to right, this graph is starting from negative infinity, and then it's going towards negative 1. And it looks like it might stop here, but we have an open dot here, or a hole, but the x value is closed or included here, so we're going to keep going. The x value is included here, but not here, but it is included once, so we're going to keep going, and it looks like it goes all the way towards positive infinity. So my domain is negative to positive infinity, because every time there is a hole, it's actually filled in above. The range is all y values, and we're going from the bottom to the top. So if I start at the bottom of my function, we are again starting down here at negative infinity. But then my graph seems to end at this point here at negative 1. Now it looks like we have an open dot here. It looks like we have an open dot here. However, negative 1 is included everywhere along this line. So I would say that negative 1 is actually included. So my range so far would be negative infinity to negative 1 bracket, because again, it is included here. I know it's not included here and here, but it is somewhere. Union, the lowest value here is 1, and that is included as well. You can assume that any point on the graph, if not a hole, is included. And then the highest value it reaches here at 1, 2, 3, 4, 5. So it would be 1 to 5, both bracketed. All right, guys, that's the end of this video. You'll pick up with Mr. McConey here with number 26.